Alright, so we're going to do our first stoichiometry problem, and that is going to be the simplest of any stoichiometry problem, and that's called a mole-to-mole stoichiometry problem, because we're really only going to need the mole ratios from the balanced equation to get our answer. It doesn't involve mass or grams here, it just involves looking at moles. So let's take a look. How many moles of water will be produced from 5 moles of ethanol? And it has our ethanol combustion reaction already written out and balanced for us. So the two things I'm going to deal with here would be my ethanol, which we notice has just a 1 in front of it. I'm going to go ahead and write the 1. And I know from the reaction that the ratio of ethanol to water is 1 to 3. So for every 1 mole of methanol reacted or combusted, I get 3 moles of water. So I'm going to set up my bracket system. How many, what am I trying to find? Moles of H2O are needed for, what was my given value right there? 5.0 moles of ethanol. Now, we've talked about in class how different types of stoichiometry problems require different numbers of brackets, this being the first bracket, this being the second bracket. And again, all this is a couple of fractions. And I've taught you in class if you want to separate these out, that's fine. But I'm going to have to, either way, figure out using fractions, whether you write it as a bracket or whether you write it separately, it doesn't really matter. So as I taught you in class before, whatever you're trying to get rid of, you're going to put on the bottom, because it's opposite, diagonal from the given value. And whatever you're trying to find goes on the top. So I need some sort of relationship between moles of H2O and moles of C2H3OH, which is the ethanol. And I look up here at what I've already written out, and I see that I have a ratio that says 1 mole of ethanol is equal to 3 moles of H2O. So next to ethanol, I'm going to put a 1, because of my 1 right there. Next to H2O, I'm going to put a 3, because of the 3 right there. My units, moles of ethanol, cancel out. I'm left with moles of H2O. And when I go back and I look at what I was given, moles of H2O, that matches. Moles of H2O here, moles of H2O here. So I know I'm done with my conversions, and all this really is just a matter of multiplying my numerators here. So 5.0 times 3, that's going to give me 15 moles of H2O. And that makes sense. Think about it. For every 1 mole of ethanol, you get 3 moles. So you get 3 times the moles of water for every 1 mole of ethanol burned. And of course, if you have 5 moles, 3 times that gives you your 15 moles. And that's how you do your standard mole-to-mole